Hi everyone, let's take a look at the following. In the first video of the review section, we did part D. We're going to move on to part E. Sketch the following. F of x equals to x squared minus 1 divided by x to the power of 3. Step 1. Before we look at the domain, because this is a fraction or a rational expression, start with the vertical asymptote, horizontal asymptote, and oblique asymptote. So by inspection, if you look at the function x squared minus 1 divided by x to the power of 3, the denominator cannot be 0. So x cubed cannot be 0, or x cannot be 0. This means the vertical asymptote is located at x equal to 0. If you look at the horizontal asymptote, and again, I know you can go through limits, there's a lot more steps you can show, but ultimately, you look at the exponent at the top and at the bottom. And notice how the exponent at the bottom, 3, is larger than the exponent at the top, which is 2. This means there will be a horizontal asymptote at y equal to 0, and because you found a horizontal asymptote, this means there will be no oblique asymptotes. So you always want to graph this as you go. Please do not graph at the very end. Make sure you label the horizontal asymptote and the vertical asymptote respectively. Let's keep going. Once you write down the asymptotes, of course the domain is now going to be x as an element of real numbers such that x cannot be 0. So again, here's another reminder in case you haven't watched the other videos. Domain is pretty much related to the vertical asymptote, and range will be related to the horizontal if you want to write down range. Now, to find the interval of increase and decrease, you must first find the critical points, which means you have to find the derivative. So in this case, you have to apply the quotient rule. So step 1, you square the bottom. Step 2, you copy the bottom to the top. Step 3, you multiply by the derivative of the top, minus, you copy the top, and the final step you multiply by the derivative of the bottom. And again, you're going to set this to 0, and notice that before we continue here, the bottom here is really x to the 6. And if I use a different color, I hope you can see that there's a common factor of x squared from the top and at the bottom, just like that. So again, you can divide this into two different columns. You want to focus on the top and at the bottom to figure out all the possible critical points. So if you focus on the top, x times 2x is going to give you 2x squared minus 3x squared plus 3. And if you look at the denominator, x to the 4 equal to 0, again, this is where you want to figure out when f prime is undefined or does not exist. I'll put this in quotation marks. And like I said, sometimes they're vertical asymptotes and there's nothing you can do. And in the second column, x equal to 0 is a vertical asymptote, so that's not going to be a critical point. In the first column, if you solve this, 2x squared minus 3x squared is negative x squared plus 3, which means x squared is going to be 3. Don't forget there are two cases. When you find the square root, there's a plus and a minus that you have to look at. So x equals approximately 1.7 plus or minus. And again, really important, you find the critical points, not just the x value, but the points, which means you can take 1.7 plus or minus, plug it back to the function. Feel free to press pause, and when you press play again, I'll be right here. 1.7 should correspond to 0.4, negative 1.7 should correspond to negative 0.4. And again, this makes sense because if you really look at this function, this is an odd function, which means it'll be symmetric about the origin. So again, form the habit of graphing as you go. So you go right by 1.7, you go up by 0.4. So 1.7, 0.4. Likewise, if you look at negative 1.7, negative 0.4, it looks something like that. Now, once you find the critical points, you can move on to intervals of increase and decrease. Now be very careful, right? A lot of students would look at this and say, okay, I got the critical points, negative 1.7 and 1.7. But be very careful. You must include vertical asymptotes, which is x equal to 0. And again, you can take your calculator, and I'll be right here when you work this out. You plug it back into f prime. And to be clear, f prime of x equals to negative x squared plus 3 divided by x to the power 4. So again, plug in those numbers. When you work them out, you should get decreasing, increasing, increasing, and decreasing. And again, this is an agreement in terms of its symmetry, which is an odd function. So let's keep going. Once you find intervals of increase and decrease, you can find the points of inflection, which means we define f double prime. So again, you apply the quotient rule. Step 1, you square the bottom. Second step, you copy the bottom to the top. Step 3, you multiply by the derivative minus, you copy the top. And the final step is you multiply by the derivative of the bottom. Again, your goal is to set this to 0, solve for x, but notice how the bottom is x to the power of 8. Let me use a different color. There's also a common factor of x cubed from the top and also from the bottom, which means if you only focus on the top, that's going to be negative 2x squared plus 4x squared minus 12. So let's draw the line, divide this into two different columns again. In the second column, again, you could say x to the 5 is 0. This is the same idea as critical points where you want to figure out when, in this case, f double prime does not exist or undefined. And like I said, in most cases, it's a vertical asymptote. So this won't be part of the inflection points. But in the previous example, if you go back to the previous video, in that one, you find additional critical / inflection points. Now, back to the first column. Negative 2 plus 4 is going to be 2x squared minus 12. You can bring this to the other side. You can even divide both sides by 2. Again, there are two cases here, plus and minus. So I'm going to work this out with you in real time. If you take the calculator and you take the square root of 6, that's going to be approximately plus and minus 2.4. Again, really important that you go back and you find the inflection points, not just the x value, but the actual points. So if you plug in 2.4, that should give you approximately 0.3. 0.3. And likewise for negative 2.4, it should be negative 0.3. If that's not in agreement with you, you can comment below and I'll address them accordingly. So again, go back to the graph. 2.4, 0.3, which would be roughly somewhere here. 2.4, 0.3. Likewise, on the other side, there's negative 2.4, negative 0.3. So negative 2.4, negative 0.3, inflection point. This is also the inflection point, just like that. Okay, let's keep going. Once you find the points of inflection, you can now move on to concavity. So you draw the line, and again, a lot of students will look at this and say, okay, the only points that matters are negative 2.4 and 2.4, and that's simply not true because you have to think about the vertical asymptote. So again, for both increasing, decreasing, and for concavity, always include the anchor points, which are vertical asymptotes. Again, you can take the calculator and work this out. Maybe I'll do some of these with you just to make sure you see what I'm doing here. When you look at f double prime, this equals to 2x squared minus 12 divided by x to the power of 5. Okay, so for example, let's say I pick a number less than 2.4. Let's say I pick negative 5. So I'm taking the calculator. I'm doing this with you in real time just in case it doesn't work. And I want to make sure you see what I'm doing. So I plug in negative 5, and when I work this out, it's negative 0.01216. It's basically negative. This means it's going to be concave down. Now, the rest of this, you can press pause, just keep going. You got this. You can do this. So this is going to give you concave up, concave down, concave up. And again, this is in agreement with the fact that the function is an odd function, which means it's symmetric about the origin. So again, this is the other part I want you to think about as well. Don't just copy and kind of follow this. I know you can follow this, but I want to make sure that you can do this on your own. So this is the superposition of all the increasing, decreasing, and this is how you're going to graph it. So again, there's negative 2.4, 2.4, there's negative 1.7, positive 1.7, and of course there's the vertical asymptote, which separates everything else. So again, if I just go back and copy this, this is decreasing, decreasing, increasing, increasing, decreasing, decreasing. If I look at the concavity, that's going to be concave down, concave up, concave up. Then it's concave down, concave down, concave up. Again, press pause, draw each part of the function, and then we'll reconnect them. When you press play again, I'll be right here. Here we go. If it's going to be concave down and decreasing, it's going to look like that. Concave up, decreasing, concave up, increasing, concave down, increasing, concave up, concave down, increasing, then concave down, decreasing, and concave up, decreasing. So if you connect them, here's what happens. Again, we're following all this idea. So roughly speaking, it's going to look something like that. Then it's going to be like that. And it's going to go straight up to the vertical asymptote. And because it's an odd function, you can almost even predict the second part that looks like that. Then it's going to continue concave down, concave up. And that's going to be the function f of x. And again, notice a couple of things I didn't do with you. And I'll leave that to you. You can comment below, and I'll tell you if you're doing it right. This is very straightforward. I don't want to tell you the answer right now. I'm almost giving it away. My question is, what is the x-intercept? And I want you to really do the math. Don't just look at the scale and say, oh, this is plus and minus, whatever. The other thing I haven't talked about is this is the maximum. This is the minimum, right? And again, you have the option of going back to the first derivative test or the second derivative test to show the local max or local min. And this is how you graph f of x equal to x squared minus 1 all over x to the power of 3. I hope this makes sense.